Welcome to massive online open course on cartographic technique. Myself Dr. Sivasankar, Department of Geography, University of Madras. Today let us discuss about zenithal or azimuthal projection. So, it is a continuous to previous lecture. So, we already discussed on projections and different types of projections also we have discussed. Azimuthal projection today. Introduction. Map projection, method of representing earth on the flat surface. So, look at this picture. So, earth is like this. Okay. We are converting this three-dimensional earth surface into flat two-dimensional surface like this. So, this is the simple definition of map projection, and let us understand zenithal projection. Zenithal projection nothing but, so already we have discussed about the cylindrical projection and conical projection. Okay. So, let us understand what is zenithal projection. Okay. Zenithal projection nothing but it project the point from the globe on the plane. Okay. Assume that this is the globe and just we are choosing any one point on the flat surface. Okay. So, here when you look at cylindrical projection, now we have covered the entire equator region, whereas in conical we have covered mid latitude countries, whereas in zenithal projection we will be just selecting any one point on the globe and we will start projecting. Okay. So, that is known as zenithal projection. The plane touches globe on one point, the center or zenith. Meaning of zenithal and azimuthal projection, it is very simple. Zenithal nothing but projection centered at the one point directly overhead. Okay. So, assume that this is the point which you have chosen, just touch this point alone where you can have more accuracy. So, in order to understand better, look at this picture. Okay. Just we are touching any one point on the globe, okay, overhead. When we start understanding azimuthal projection, it maintains the accuracy of direction from the center point. Already we know like the types of distortion, shape, area, distance and direction. Here what happens, it preserves the direction. Okay. From the center point it preserves the direction. So, that is the reason why most of the navigation purpose we are using this projection. Okay. Let me repeat again, zenithal nothing but to touch any one point directly overhead. Okay. Azimuthal nothing but to maintain the accurate distance. Okay. So, this is the difference between zenithal and azimuthal. So, when we talk about the general characteristics, it touches globe at one point of tangency, just now we have discussed. Okay. Any one point it touches. Direction from the center point are preserved. Okay, assume that this is the point which you have selected. From here the direction will be preserved close to the center point, whereas its move away from the center point it may get distorted. So, that is the simple meaning of this particular point. The distortion increase away from the center. Obviously, for every projection where the particular point is being touched, that is a place where we can have more accuracy. If you are moving away from the center point, then there is a chance of distortion. Okay. So, this is the overall general characteristics about the projection. Then point of tangency. So, here when you touch north pole like this. So, this particular area get projected in south pole and equator, even oblique. Okay. So, this is for north pole, when you touch the projection plane somewhere over here, okay, then we can project this particular area, which means the northern pole. If you are touching on the equator, the complete equator area will get projected. When you are touching on the oblique, like in between polar and equator, this particular region alone will get projected. This is mainly for like if any zones or any country falling between polar and equator area, we can go for oblique type. Okay. So, wherever you are touching, like touching the place on the globe, that area alone will get projected. This is for polar region, touching the plane on the northern part of the globe. If you are touching the globe on equator, so this is the place where the complete equator area will get projected nicely. If you are touching an oblique type like this, the area between polar and equator, this particular area alone will get projected nicely. At the end of the day, we are touching any one particular point on the globe. So, that particular point will have more accuracy. If you are moving away from that particular point, we may experience a distortion. Let us understand the different types of zenithal projection. So, we can have 5 classification, 5 types. One is mnemonic projection, the second one is stereographic projection, the third one is orthographic projection, the fourth one is azimuthal equidistance projection, the fifth one is Lambert azimuthal equal area projection. So, let us discuss one by one and its usages. Mnemonic projection, let us understand how it works. Direction true from the center. As I said earlier, let us say this is the center point, the direction true from the center like this. So, we can have appropriate direction from the center. Great circle straight line, shortest path between 2 points. A great circle nothing but the distance between any 2 point. So, that is known as great circle, and distance and area distorted, only direction from the tangent point are preserved. As I said earlier, it preserves only the direction. From the center, it will preserve only the direction. When we talk about the other property in terms of distance, in terms of area, it may not be preserved. There you can experience inaccuracy or distortion. So, this particular projection type, it retain the direction, that too from the center point. If you are moving away from the center point, there are chance of inaccuracy, and it retain only the direction, and distance and area may get distorted. And we look at the usage in real time application, air and sea navigation, they are using it very effectively. Why? Because it is very simple, it retain the direction so precisely, so that we can get the accurate result. Again, for shortest route planning also, it can be used very effectively. Then let us understand the next projection type, the second one, that is stereographic projection. The projection from the point on the globe opposite to the tangent point. So, look at this picture. Okay, we are projecting the globe from the opposite side of the globe. From here we have started projecting like this. So, this is the projection point, and this one is equator, and this is the projected plane. Okay, when you project from here, so this is how it will get projected like this. Okay, you can see the example here. Conformal projection, it preserves the shapes. As I said earlier, shapes, area, distance and direction. So, it preserves shapes. If you look at any country, it preserves the shapes of the country or area. Okay. This is mainly for retaining the shape, whereas area and distance, direction may get distorted. And when I say conformal projection, it preserves the shapes locally. It is for when you apply this for globally, probably you may face some error. When it is applied for local area projection, probably you may have a better result. So, it preserves only the shapes. Okay. Let me highlight here, it preserves the shapes. So, this is the overall idea about the stereographic projection. When we talk about the characteristics and property and usage, and angles preserved, distance and area distorted. Okay. Here only the angles will preserved or shapes will be preserved, whereas distance from the center point, shapes can be preserved. Okay. When you talk about distance, when you talk about the area, it is highly distorted away from the center point. So, this is the core idea. So, the area it falls near to the center point, where you can have higher accuracy measurement. It is away from the center point, then probably we may face some accuracy issue. So, here especially distance and area may get distorted away from the center point. Okay. When you go for use cases, real time application, polar chart, especially for navigation, meteorology. Okay. When you talk about astronomy, where we can use it for star map, celestial bodies and creating different chart. So, everywhere we can use this. Okay. Here again let me repeat, here we can preserve angle or shape, whereas in terms of distance and area it is highly distorted. Let us understand the third projection system, that is nothing but orthographic projection. Okay. So, let us understand how it look like. Imagine looking at the earth from the space. If you look at the earth from the space, how it appears, that kind of appealing you can have it here. Okay. The earth projected with the parallel light rays like a sunlight. Look at here, earth are projected like this. This is the direction of sunlight. Okay. It is like a parallel lights. So, you can see this parallel light. So, like this. So, from here we have started projecting this map. Okay. The earth projected with the parallel light rays like this. Third one is, it shows half of the earth or one side of hemisphere as a circle. Okay. So, look at this, it is not showing the complete one, it is showing only the half of the size and hemisphere, okay, as a circle. So, like this. Middles look correct, but things near the edges look stretched. Similar to the other projection what we have seen, the middle area we can have more accuracy, but near to the edges it is highly stretched, or you can have the inaccuracy issues. Okay. And if you look for the use cases, the real time application to make globe like pictures, okay, globe like pictures and all, you can use this projection. Then the final one is artistic and decorative map. Okay, not to a decorative, or if you want to create any in the way of appealing look, you can use this projection. Azimuthal equal distance projection. This is the fourth projection system, where the name of the projection itself clearly says that azimuthal equidistance, which means we can directly say that it retained the distance. Okay. Distance are correct from the center point. Same way, assume that this is the center point you have selected for projecting your map, and near to the center point you can have a accurate distance. The direction from the center also accurate, even not only the distance, even the direction also, direction from the center also accurate. So, here it retained two properties, one is distance, the other one is direction. Okay. Distance and direction. Looks like earth seen from above one point. If you looking the from the earth from above point, how it appears, so that kind of appealing look it gives. Okay. Let me repeat again, the distance are correct from the center point to anywhere on the map, it retain the distance so precisely. The second one is the direction from the center point also accurate. Okay. So, it retain both these through two properties, and use cases you can see all air routes they are using it very effectively. So, all of us we know, like in order to have any it is air route or any route or navigation whatever it may be. So, direction and distance matters. So, in order to retain these two properties, in order to preserve these two characteristics, we have to use azimuthal equidistance projection. The last projection, okay, under this category, like Lambert azimuthal equal area projection. So, the name itself clearly says that equal area projection, which means that obviously it retained the area. So, precisely, so equal area, size of the region are shown correctly, shapes may look like stretched, which means the area it retains so precisely, so that in terms of doing any area calculation like land use or any resource or any population density calculation, area measurement is very, very essential. In order to pursue all this analysis, in order to do all this analysis, we have to use equal area projection, especially for land use and all. You need to have the appropriate measurement of every individual land use. So, by the time this particular projection system will be very useful. Areas are true, that is what we are retaining the area. This particular projection will preserve the area, whereas size wise there will be a distortion. Okay. It is good for showing the entire hemisphere. So, if we want to project, if we want to show the entire hemisphere, so you can directly use this equal area projection like this. Look at this picture. Okay, equal area, look at this circle. Let's say it is a 500 meter or else 500 kilometer radius. Okay, that shapes are retaining till here. Okay, from here it is getting distorted. So, like this, you can retain the size. It remains same. Okay, this entire hemispheres it retains the shapes. So, if you are working with area calculation as a geographer, as a cartographer, you can directly use this equal area projection. The complete hemisphere you can project. So, use cases and real time application where you can use this projection for population, as I said earlier, in terms of area and number of population, you can directly go for this projection, and resource calculation, land use studies, where and all the area matters, where you need to have high accuracy area in terms of measurement. Directly you can use this equal area projection. And creation of thematic map like climate and environment, also here we can use it. Then if you look at the other characteristics, Lambert azimuthal equal area projection, okay, as I said earlier, it preserves the area, shapes distorted away from the center point. Okay, same thing. If you look at the shapes, so here and all shapes are retained. If you moving away from the center point, so that is distorted. Okay, so this particular point you have to be very, because we are choosing any one point. So, wherever the place which is very close to that center point, where you do not have any accuracy issue. If you are moving away from the center point, so you started facing all the distortion issue. Okay. Here if you look at the shapes near to the center point, it retained. If you are moving away, that shape also getting distorted like this. If you look at the use case for population density map and land use study, everywhere you can use. As I said, the same previous slide also we have discussed, in order to retain the area calculation, and not to have the accurate measurement in terms of area calculation, we can use this projection. Then let us get into the next aspect, polar aspect. If you are touching your the flat surface or whatever it may be on the globe side, I mean northern part of the globe side, okay, the projection surface touches the northern pole or southern pole, the maps is center on the pole. Yes, assume that this particular area you are going to project. So, you have chosen this point, then the map center on the pole. Okay, map center always on the pole, and the in and around that central point you can have accurate result. Look like earth seen from above pole. If you are seeing the earth above from the pole, how it look like, the same thing you can see it here. So, look at this picture like this similar, okay, like this you can have this view. We are seeing the globe from the the aerial view. So, similar appearance you may get it here. When you talk about the use cases or application front, polar chart, weather, navigation, ice, for any study which is related to the polar front, you can use this polar aspect, like you can touch base on the polar area where you can work on the projection. Equatorial aspect, where the same center point you are touching on the equator. When I say equator, this complete area projected nicely. So, projection surface touches at the equator. So, this particular area we can project nicely. Map is center on the equator region. The previous polar aspect what we have seen, map is center on the polar side, like polar side, whereas equator aspect it is center on the equator, best for using the area which is near to equator. In equator you want to touch, you want to project any particular area, you can go for this aspect, equator aspect, so that it will be center on the equator and this particular area will get projected nicely. So, this is mainly for in terms of use case, this is mainly for mapping the tropical regions, okay. Of course, these particular regions, showing the countries along the equators. If you want to show the countries along the equator, and probably you can use this equator aspect, okay. So, now we have seen pole aspect and equator aspect. Let us understand oblique aspect. If any area falling in between polar side and equator side, in between these two areas we want to project, then you can use polar object, okay. Projection surface touches the globe at any point, not polar and equator. So, which means in between equator and polar, okay. You can use this aspect, oblique aspect. The map centered on tilted view. So, for when you look at the previous slide, this is center on the pole, polar aspect, this is center on the equator region, this is center on tilted view, okay. And it is useful when the area intersect between polar and equator, okay. So, it is not completely polar, it is not completely equator, the place where intersecting between these two zones we can use this oblique aspect. When you talk about the use cases for regional mapping, we can use it very effectively, we can use it, and flexible for showing specific continent and country. So, suppose you want to be specific with one country or specific with one continent, in order to have a complete, instead of having the complete hemisphere approach, just you want to highlight any one country or continent, then you can use this oblique aspect, okay. So, it is in between polar and equator, it is it is a oblique view, okay. It is tilted, and if you want to be specific with any region or any country or any continent, you can use this one, okay. It will be very effective. Distortion pattern, okay. So, distortion get bigger outerward from the point of center. So, now it is very clear that from the beginning I am keep on repeating this point, distortion may not be avoided if you keep moving away from the center point. Close this to the center point we can have a high accuracy output. If you started moving from the center point towards the periphery area, then there is a chance of getting distortion. Shapes, distance and area correct only the near to the center. Yes, of course, shapes, distance and area correct near to the center point. If you started moving away from the center point, you can see it very clearly here, everything is getting distorted. The core idea is the touching point, where using that plane where you are touching on the globe, okay, that particular area alone will get projected nicely, and where you can have a minimal distortion issue. If you are moving away from the central point, then you can have more distortion, okay. So, accordingly you have to take a call, okay. So, very simple, if you want to project one area, let us say one region, or if it is one country, ensure that that countries or that particular region center point you have to place it, so that the complete region or complete country or continent, it will get projected nicely, so that the periphery part away from the center point, so which are the countries or regions are falling, it is automatically distorted. So, you focus on your study area, which point you are going to select or which region you are going to select, you make a center point of it, so that you will not be getting any distortion issues. You can have high accuracy output. This is a simple mathematical formula in general. Okay, radius r depends on latitude p and longitude lambda for different types of projection. This is the different types of formula which been following. So, mnemonic projection r tan 90 degree minus p, stereographic r equal to 2 r tan 90 degree minus p divided by 2. Okay, orthographic r equal to r cos p. Let us talk about the advantages of zenithal projection. Okay. So, it is so accurate in terms of direction from the center point. So accurate in terms of direction. As I said earlier, suppose you have taken one region as a study area like this, choose midpoint of that particular study area. Okay. So that from mid of that study area, if you start projecting that particular region using zenithal projection, if you are working with direction, so that complete area will have the excellent result of the which means the direction wise there won't be any error at all. You can have an excellent result and excellent output. There won't be any accuracy issue. Okay, the selecting the center point, it's a matter. Okay, the direction. Okay, so working with the direction, then you have to choose the center point. Okay, from the close to that center point, we can have more accurate result. Okay, useful for navigation and communication map. When direction come into picture, always navigation and communication maps, we can use it very effectively, and it is flexible. Okay, when I say flexible, you can use it for polar, use it for equatorial, you can use it for oblique. You can decide. Okay, you can decide. Okay, if you want to work with polar, yes, you can move it to polar, where you can select one particular point. If you want to work with equator, where you can select one point, only that equatorial area will get alone projected. Oblique, in between polar and equatorial, if you want to choose any point, there also you can choose it. Okay, it is highly flexible. Okay, depends upon your project and depends upon your need, you can shift anywhere in between these 3 points. Limitation: distortion increase away from the center point. That is what I keep on telling. There is a major disadvantage, or it is a limitation. So that distortion we cannot avoid when we move away from the center point. Okay. Not suitable for global map with equal accuracy, of course. Okay. You cannot use it for, because there is a distortion issue, right. Moreover, here we are picking only one point on the globe. So we cannot use it for the complete globe map. If that is the case, then we will be having accuracy issue. This is for one particular area or one particular zone or one particular country alone, we can use it. In terms of global application, in terms of complete global coverage, probably we may not use this projection. So only useful for hemisphere or regional mapping. Any one hemisphere if you want to use, or any regional planning if you want to work with that, you can use this projection. And this is the major limitation. And in terms of flexibility, we can use it in anywhere on the globe. Application summary: again, you have to decide as suppose if you are a geospatial working professional, or if you are a cartographer or map maker, whoever it may be, you look for the requirement. Okay, whether if you want to work, say any project which deals with navigation, then probably you can use mnemonic and azimuthal and equidistance. Okay, if you are working with astronomy and polar study, probably you can use stereographic, and if you have a good visual representation, probably you can use orthographic, and if you are working with thematic or statistic map, you can go for Lambert equal area projection, where area matters. If you want to preserve the area, where you do not want to compromise with the area measurement, you can directly go for Lambert equal area projection. Again, as a application front, as an expert, okay, you have to decide based on your project requirement, based on your work, you have to decide which projection system you are going to use. Okay. When we conclude, okay, let us understand this point. Zenithal projection essential tool for cartography. Okay, this is very essential. Zenithal projection, that too for point based, it is very essential. Choice depends on the purpose, whether navigation or area or shape or visual. You have to take a call. Whether if you want to work with the navigation, you have to choose appropriate projection. If you want to work with area, you have to use Lambert equal area projection. Not to retain the shape, if you want to retain the shape, you have to use appropriate. Again, you have to take a call. So, you have to understand your project requirement. As per that, you have to work on your projection. Okay. Key idea, all the direction from the central points are preserved. In terms of direction, from the central point is highly preserved. Very simple, from the central point all the directions were preserved. Okay. Overall understanding of zenithal or azimuthal projection, and as a geography student, as a geospatial expert, you need to take a call while deciding the projection. Okay, you have to see the requirement, you have to see the project requirement, and you have to decide whether it is a navigation or area or shape. So, based on that you have to choose the appropriate projection, so that the accuracy level will be high. If you are choosing inappropriate projection, then you may have accuracy issue. Thank you so much. Thank you for your time.